Okay, so here we're going to be talking about finding the zeros of quadratic functions. And we've talked about finding zeros before. It's basically just the x values that make the function equal to 0, that make the y value equal to 0. So we're looking for x values that make the entire function equal to 0. Another way to see this, just on the graph, it's basically just the x-intercept. Where does this graph hit the x-axis? There's a few different ways we can say this. But they all mean the same thing. They're all looking for x values that make the y value or the function equal to 0. We're looking for x values. We're always looking for the x values that make a y, or another way to say that is f of x makes the function equal to 0. And some synonyms for a 0 are roots, solutions, and x-intercepts. Those all mean the same thing. They're just x values that make the function equal to 0. On a graph, it's really just picking out the x-intercepts. So we're just looking at the points where this hits the x-axis. That's 1. That's the second one. 3, 0, and 5, 0 are the two roots or solutions. That's written as ordered pairs. If you wanted to say x equals 3, 5, actually I don't really want to write a comma in between there because that kind of looks like an ordered pair again. I'm going to say x equals 3 or 5. Those are both saying the same thing. We're talking about the x values that make the y equal to 0. You can write it as an ordered pair or just the x values. When we're looking at a function like this, we're looking at which of those x values we can plug in for x and make the function equal to 0. So we're going to take each of those and plug them in. Negative 12 in place of both of those x's. Anytime we substitute a number in, it should go in parentheses, especially when we're dealing with a negative number being plugged in for an exponent. When we evaluate this, we're going to do 12 squared, that's 144, minus, really that's going to become a plus because it's a negative times a negative, that becomes plus 24, minus 20, that equals 48. That is not what we're looking for. We're looking for the answer, the f of negative 12 should equal 0, but it doesn't. That is not a solution or an x-intercept or a root or a 0 of that function. Next, we're going to plug in 10. 10 squared is 100, minus 10 times negative 2, or really minus 10 times 2 is 20, so that becomes 80, minus another, oops, I missed the 1 there. Minus 120 is negative 40. That's not what we're looking for either. It's supposed to be 0. I'm going to plug both of these last two in. X is now 8. 8 squared is 64, minus 2 times 8. That's now 48. Minus 120 is negative 72. That's not what we're looking for either, so just by process of elimination, it should be D. Let's just make sure. I'm going to plug in 12. 12 squared is 144, minus 2 times 12. That is 24, so 144 minus 24 is 120, and then minus 120 equals 0. That's what we're looking for. That is our x-intercept, or at least one of the x-intercepts of that function. On this one, this is actually not a quadratic. We're looking at a cubic function. It would look something like this. It's not an x squared, it's an x cubed. So we're actually looking at 3 different solutions here. Anytime that hits the x-axis, we have a solution. So we have 1, 2, 3, x equals, I'm going to put this in a bracket to show all of my x-intercepts. Negative 3, 1, and 2 are all solutions. Again, you can list those out as ordered pairs. Negative 3, 0, 1, 0, and 2, 0. All of those are zeros of the function because y equals 0, and those are the x values that make y equals 0. In letter D, we're trying to find all of the solutions of that function. That's a lot of points to plug in. This is really why we're going to learn a new, quicker way to figure out how to quickly get to the solution. And we're going to be using factoring. Actually, I'm going to preview that here. I'm going to factor this. I'm going to factor that polynomial. So I have a value that's not 1, so I'm going to do a times c. That would be negative 80. A times c is negative 80. My b is 11. I'm looking for stuff that's going to multiply to give me negative 80 and add to give me 11. That is going to be 16 and negative 5. 16 times negative 5 would give me negative 80, and 16 plus the negative 5 gives me 11, which is exactly what I need to break up this middle term. 4x squared plus 16x minus 5x minus 20. Now I'm going to factor by grouping. I'm going to group those two, I'm going to group those two, and then I'm going to factor out the GCF from the first set, the 4x squared and 16x. I'm going to divide each of those by 4x. 4x comes to the outside of the parentheses. It leaves me with x plus 4 on the inside. And then minus, I'm going to divide this by negative 5 and this by negative 5 to make these parentheses the exact same. Those have to be the same, so I need to factor out a negative 5. So I'm just going to rewrite the equation with my two factors instead of the original polynomial. I'm going to factor that into 4x minus 5 times x plus 4. And this makes it a lot easier to see what my two solutions are. And it means I don't actually need multiple choice options. I'm trying to think about what's going to make this equal to 0. How can I get y equal to 0? I'm going to deal with the easier one first, and that's this one. So first off, I'm multiplying these two things. I'm multiplying 4x minus 5 and x plus 4. So if either one of those two things became 0, then the whole thing is 0, because I'm multiplying by 0. So if I can somehow get this set of parentheses equal to 0, then this entire thing would be equal to 0. So that's actually exactly what I'm going to do. I'm going to set that equal to 0. I'm going to say x plus 4 equals 0. That's going to tell me one of my solutions. I'm going to do that with the other parentheses also. This can also be set equal to 0. 4x minus 5 equals 0. And now I'm just going to solve those equations. I'm trying to figure out what the x value needs to be to make that equal to 0. The top one would just need to be negative 4. And the bottom one would need to be 5 over 4. So my two solutions are E and A. Again, when these are multiple choice, you can work backwards from the answers. You can just plug those in and see which one makes the y equal to 0. Those should both work. Or, like we're about to learn, you can factor each of these and then set each of the factors equal to 0. And whatever makes one of the factors equal to 0, that or that equal to 0 is a solution. It's going to make this entire thing, the whole function, equal to 0. That's what these steps are going to walk us through. So now we're finding the zeros using the factor. So our first step is obviously just factor. We're going to factor the quadratic expression. When it says quadratic, we could have no solution. We could have one solution. Or we could have two solutions. Quadratics are always going to look like this, or upside down, that. Those are called parabolas. We're going to learn more about this on Monday, but excuse me. But a quadratic is always going to form a parabola on the graph. So each of those two, actually let's go back, those two each have two solutions. There, and there, there, and there. They hit the x-axis twice. We could have a parabola that looks like this. That does not touch the x-axis ever. That has no solutions. And we could have something that just touches it one time, a parabola that just nicks it that one time. Actually, kind of missed, but it's going to just touch it that one time and then go off and never hit it again. That would be one solution. And we're going to talk about those special cases a little bit later. So the first thing we want to do is just factor. Then we're going to set each factor equal to 0 and solve for those variables. Solve each of those separately for the x factor. And we can always plug our answer back in. Plug back into the original polynomial to make sure that it actually makes it equal to 0. It's basically what we've been doing where you plug in the multiple choice options. But this is just checking your answer. So my first step is just to factor this. F of x equals, I'm looking for, so since my a is 1, I'm really just looking for something that's going to multiply to be a positive 10 and add up to be a negative 7. That's going to be a negative 5 and a negative 2. Now I'm going to set each of those equal to 0. X minus 5 equals 0, and x minus 2 equals 0. I'm solving for this x value. I'm going to add that 2 over, so x equals 2. That's one of my solutions. The other one is kind of the exact same thing. I'm going to follow the exact same steps. I'm adding that 5 over to cancel out the minus 5, and x equals positive 5. So those are my two solutions, x equals 2 and x equals 5. Those are the two zeros of this function. And you can see that they're basically just the opposite signs of the roots. When the x is 1, when the a is 1, it is really just the opposite signs of each of those factors. On the next one, I'm going to factor out at 2 first, so I could do a times c, but I really don't want to because I can see that there's a greatest common factor in each of these that's going to make a equal to 1 and make that completely unnecessary. So I'm just going to factor this in first by taking out 2 from each of those. That leaves me with a squared minus 6a plus 5. And now my a, the number in front of this a squared term, the a, is 1. So I'm just looking for something that's going to multiply to be positive 5 and add up to being negative 6. That's a negative 5 and a negative 1. Now I'm looking for things that are going to make either of those two factors equal to 0. So I'm going to set them equal to 0. And then I'm going to solve for a. A equals 5 in this one. And a equals 1 in that one. Those are my two solutions. You can plug those right back into the original polynomial. You plug in 5, or you can plug in 1, but you do those separately. You don't do it at the same time. You plug in 5, and then separately you can plug in 1, and they should both make it equal to 0. All right, number 3, I'm going to try to factor that here. I can rewrite this b squared minus or plus 0b minus 81. So I'm looking for something that's going to multiply to be negative 81 and add up to 0. They have to be two opposite numbers. If they're adding up to 0, they have to be opposites of each other. So that's going to be b minus 9 and b plus 9. Then I set each of those equal to 0. B minus 9 equals 0. B plus 9 equals 0. This would give me a positive 9. This would give me a negative 9. Those are my two solutions of number 3. Number 4, I'm going to factor out the GCF first. So you can see that there actually is no C. Usually we'll have a constant that's added onto this, but we don't have anything there, so I'm going to find the GCF of this first. That's always your first step. If you can factor out a GCF, take that out first. Here, it's going to be an x. these both have an x in them, so I can take an x out and put that on the outside of the parentheses, leaving me with 3x. Actually, excuse me, I can take out more than that. I can take out 3x. 3x and 3x factor out of each of those. I'm going to divide each of them by 3x. This becomes x, this becomes a negative e. I have two factors here. I need to set each of them equal to 0. I have, this is one of my factors, and this is my second factor. Anything that makes 3x equal to 0, and anything that makes x minus 8 equal to 0 will work to make the entire function equal to 0. Here I'm just going to divide by 3 on both sides, and x equals 0. That's one of my solutions. And I'm going to add 8, that gives me that x equals 8. So 0 and 8 are zeros of this function. Those are two x values that make this function equal to 0. All right, number 5, I'm going to have to do a times c because this is not 1. So a times c here would give me a negative 72, and b is just a negative 1. I'm looking for two numbers that are just 1 apart. They're going to add up to a negative 1, and they multiply to be a negative 72. So I'm going to split this into a negative 9x and a positive 8x. They add up to a negative 1, and they multiply to give me that negative 72 that I need. Now I'm going to factor by grouping. I'm going to take something out of here. That's going to be a negative 3x. Could also be a positive 3x. That won't change anything. I'm going to divide each by a negative 3x. That gives me 2x and a positive 3. And then I have to divide this and this by something that gets me that same set of parentheses, 2x plus 3. I'm going to divide each of those by 4, positive 4. So I have my two factors now. F of x is really the same thing as 3x plus 4 times 2x plus 3. Now I have to set each of those equal to 0. Negative 3x plus 4 equals 0, and 2x plus 3 equals 0. Both of those need to equal 0 to make the entire function equal to 0. So I'm going to subtract 4 from both sides on this one. That gives me negative 3x equals negative 4, and then I divide by negative 3 on both sides. X equals a positive, and negative divided by negative is the same thing as a positive divided by a positive, so it's a positive 4 over 3. On the next one, I'm going to subtract 3 from both sides. I'm trying to get x by itself, so I'm working order of operations backwards. I have to subtract 3 first. It gives me 2x equals negative 3, and then I divide by 2. That gives me a negative 3 halves. Those are my two solutions, 4/3 and negative 3 halves. Try that last one on your own. When we have a negative 1 here, you do need to think about a times c. So try factoring that on your own, and then setting each of those equal to 0 to find out the two solutions of that function.